Algebra 2, Chapter 8, Section 6, Natural Logs. What we're going to learn in this lesson is to evaluate natural logarithm expressions and to solve equations using natural logs. Okay, in 8.2, we learned that the number e is approximately 2.71828 and can be used for the base of exponents. The function y equals e to the x power has an inverse, and that inverse is called the natural log function. Okay, so if y equals e to the x power, then y equals log base e of x, which is commonly written to as the natural log of y. Okay, what do you notice? If the first equation is y equals e to the x power, all right, you have exponential growth. And the inverse of that, y equals the natural log of x, looks like that. So the properties of common logarithms also apply to natural logs as well. Okay, simplifying natural logarithms. Write 3 natural log of 6 minus the natural log of 8 as a single logarithm. First step, rewrite it with the power property. So it's going to be written natural log of 6 cubed minus natural log of 8. And then the quotient property, so the natural log of 6 cubed over 8. And then simplify, so it's really just a natural log of 27. Okay, so let's walk through these together. All right, first one is we could rewrite it with the power property, so we could say this is natural log of 2 to the 5th power minus the natural log of 4. Then we could write it as the natural log of 2 to the 5th power over 4. Well, 2 to the 5th power, 2, 4, 8, 1632. It's the natural log of 32 over 4, which can simplify to the natural log of 8. Answer C. Okay, next example. Write 3 natural log of x plus the natural log of y as a single logarithm. So the first one is, again, the power property. We could rewrite as the natural log of x cubed plus the natural log of y. So now we can just combine them. So it's going to be the natural log of x cubed y. So the answer would be B. Okay. Write 1/4 the natural log of 3 plus 1/4 the natural log of x is a single logarithm. Well, we can pull 1/4 out and say the natural log of 3 plus the natural log of x. Okay, so we could say it's 1/4 the natural log of 3x. So we could also rewrite it as the natural log as the 4 cubed, or the 4th root of 3x. So the answer would be B. Okay, moving on. Real-world connection. A spacecraft can obtain a stable orbit 300 kilometers above the Earth if it reaches a velocity of 7.7 kilometers per second. The formula for the rocket's maximum velocity in kilometers per second is v equals negative 0.0098 t plus c natural log r. The booster rocket fires t seconds and the velocity of the exhaust is c kilometers per second. The ratio of the mass of the rocket with the fuel to the mass without the fuel is r. Suppose the rocket is used to propel a spacecraft that has a mass ratio, okay, a mass ratio of 25, the exhaust velocity of 2.8, and a firing time of 100 seconds. Can the spacecraft obtain an orbit? So, first step, let r equal 25, c equal 2.8, t equal 100. So we're going to solve for velocity. Okay, so when we solve for velocity, we get the velocity to be 8. Well, the maximum velocity of 8 is greater than 7.7, so the spacecraft can easily obtain an orbit of 300 kilometers. Okay, so now we're going to reuse this equation. So we're going to actually cut and paste right here just because we can. Again, we're going to cut and paste just for a second because apparently we got to reuse this equation. All right, let's go to the next page. Okay. 2A, a booster rocket for the spacecraft has a mass ratio of about 15. So that's our R value for this example. My R value is 15. It has an exhaust velocity, that's my C value of 2.1, and a firing time, that's my T, of 30 seconds. Okay, we know we need to have it at least 8 seconds to make it. Can the spacecraft achieve a stable orbit above Earth? So let's plug in the values and let's see what we got. Okay, so my calculator's up. So now we're just going to plug in our values. So negative 0.0098 times, what's our T? 30. Plus, what's our C value? 2.1 natural log. Our R value is 15. So I got 5.39. So approximately 4. Well, so approximately 5.4. Well, it needed to be above 7.7, so right now the answer is no, it cannot. All right, critical question part B. Suppose the rocket, as designed, cannot provide enough velocity to achieve a stable orbit. Look at the variables in the velocity. Which alternations could be made so the rocket could be achieved? One could decrease the firing time. Yep, if we made the firing time smaller, that would work. One could increase the mass ratio. One could increase the exhaust velocity and decrease the mass ratio. Okay. And one could increase the mass ratio or its exhaust. Okay, so that would work as well. So we could use D or A to get the answer done. So again, the book made a mistake and either of those answers will suffice. Probably have to do both of them together. So moving on, next section, natural logs. So we can use the properties of logs to solve natural log equations as well. So let's just look at this one. Okay, the natural log of 3x plus 5 squared is equal to 4. So what did we, if you guys remember, what did we talk about natural logs? The natural log is the same thing as saying the log of e to whatever, right? So with that being said, we could rewrite every equation in this one. So if I had natural log of x equals y, I could rewrite this thing as x equals e to the y. Okay, and this is what we're going to do in this example. So we have the natural log of 3x plus 5 squared equals 2. Well, we can rewrite this as 3x plus 5 squared equals e to the 4th. Okay, square root each side. So 3x plus 5 is going to equal plus or minus the square root of 54.6. 3x plus 5 is going to equal 7.39 or negative 7.39. So x is either going to equal 0.794 or negative 4.31 or 0.13. And then we double check the work and it looks like they both work just fine. So let's look at ours. Solve the natural log of x to 0.1. So that's the same thing as saying log base e of x is equal to 0.1. So that is the same thing as saying x is equal to e to the 0.1 power. So let's put that to the test and see what we get. So e to the 0.1 power. I got 1.15, so the answer is B. Next one. Natural log of 3x minus 9. So we can just say that is the same thing as 3x minus 9 equal to the e of 21, which we can further say is basically e of 21 plus 9 all of that over 3. Okay. I did a lot of steps there, but hopefully I'll let you just talk through it to yourself and you can get it where it's going to be x equals this equation. So let's just plug that in our calculator. So in parentheses here, e to the 21 plus 9 divided by 3. Okay, so I got a really big number. I got 439,605,247.8. So the answer is B. Okay, last one. Natural log of x plus 2 over 3 equals 12. So that is saying x plus 2 over 3 is equal to the e of 12. Multiply each side by 3, so I get x plus 2 equals 3 times e to the 12th. So now x equals 3 times e to the 12th minus 2. See if we can plug that in our handy dandy calculator now. Alright, so here we go. 3 e to the 12th minus 2. Alright, I got $488,262. Or not dollars, 0.4. So the answer is C. Okay, moving on. Using natural logs to solve 7 e to the 2x plus 2.5 equals 20. First thing is we got to isolate the variable. So we subtract 2.5 from each side. We get 7 times e to the 2x power equals 17.5. Divide both sides by 7, so I get e to the 2x equals 2.5. Now I'm going to natural log both sides. Remember, the natural log of e is 1. So it's going to be 2x equals the natural log of 2.5. So x is going to equal the natural log of 2.5 over 2, which once you plug it in your calculator, you get 0.458. Next example. Use the natural logs to solve e to the x plus 1 equals 30. So it's going to be x plus 1 equals the natural log of 30. So x is going to be the natural log of 30 minus 1. So that's easy calculator work for us. So natural log of 30, enter, minus 1. So I got 2.401. So the answer is B. Use the natural log to solve this one. So I got e to the 2x over 5 equal to, I'm going to go ahead and subtract 7.2 to each side. So it's going to equal 1.9. So 2x plus 5 is going to equal the natural log of 1.9. So 2x is going to equal 5 times the natural log of 1.9. So x is going to be 5 times the natural log of 1.9 over 2. Again, easy calculator works. Let's do it. So I have 5. Oops, let me not cut it off. 5 times the, I don't need that, natural log of 1.9 divide that by 2, and I got 1.604. Answer is D. Okay, 2 more. So investing, and an initial investment of $100 is now valued at $149. The interest rate is 8% compounded continuously. So how long has the money been invested? So I got A equals PERT. Now it's just plug and chug. And what do you notice? Our variable is an exponent. So we get it combined where we get 1.4918 equals e to the 0.08 to the t power. Take the natural log of both sides and then just simply solve for t. Okay. So here we go. We got A equals PERT. It's worth $315.24. The principal was $200. All right. The time was 7 years. Okay, but we don't know the rate. So we got to solve for the rate. Step 1. Divide each side by 200.